for your invitation, okay, to be here. And I feel so happy, okay, to be standing here this afternoon. Why? You know, as I'm from Northeastern University, as you may know, as you know, this mansion here, this house, you know, used to belong the former presidents of Northeastern. And actually, as you enter, actually, this entrance here, actually, you may have look at it and find out actually this Northeastern logo, the big the emblem over there in the front. So I feel so honored, and also particularly actually, I wear actually the Northeastern lapel pin today to memorize this important moment here. I know I should only have 30 minutes. Okay, this might be the shortest presentation I give so far, I guess. So I will skip my introduction about myself. Today I'm going to talk about how to become a climate tech pioneer, professor, researcher, scientist, entrepreneur, or whatever. Because actually my research is about climate tech. Okay, and today I would like to share with all of you what I do, okay, in lab and out of lab, as a researcher, professor, and as entrepreneur, and beyond. Okay, and because I know this is a global CEO program, okay, so we highlight the leadership, okay, globally. So I would like to show you how we can advance ourselves, okay, in our own field and beyond our field. Okay. The first slide here just show you actually what I do. Okay, I only use one slide here, summarizing what I do in my lab. The bottom right image you can see. This image was taken about 4 years ago. So I ran marathon. Okay, and I completed a marathon, and after I passed the finish line, okay, one of the volunteers just put actually something over my shoulder. What is that? Okay, and after I went back home, I can zoom in. You see the heat sheets. So this material, what is the use of this material to keep it warm? Okay, clearly, okay, because after running a marathon, you lose heat. And this product is directly related to my research. My research is to tune the thermal radiative properties of any surface of materials. So we control reflection, transmission, or emission of surfaces. That's what I do. And we study a wide range of materials, okay, including the electric, metallic, polymer phase change, reconfigurable nano materials, hydrogen statistics. And also, applications of those materials include solar energy harvesting via TPV cells. TPV stands for thermal photovoltaic. PV cells is just solar cells. And we put a T in front. Okay, it's a thermal photovoltaic cells. The only difference between PV cell and TPV cell is the source. A PV cell, the source is sunlight, solar energy. TPV cell, the source of the TPV cell is heat, infrared energy. So we harvest those infrared energy. And also we study passive liquid cooling. That will be the topic I will present today. Okay. And then we also do the water treatment, okay, particularly about water desalination. Okay. And then some waste heat recovery, nanoscope biosensing, and quite a few different research. And last month I received 2 grants for fuel cell, the PM fuel cell, the proton exchange membrane fuel cell. That is one of the new research areas. And also, about 3 years ago, I started another research project about BTMS, the battery thermal management system. Okay, so I've been working with NASA, okay, on that BTMS project. And as you can see, my research totally focuses on 2 aspects. One, energy; the other one is water treatment. Why? As a researcher, usually, we ask ourselves, what we should do, or what research area I should work on. Normally, you may not have more options as you graduated from your previous lab. Okay, after you obtain your PhD degree, so you already put yourself in a really narrow research field. But how could you name or find a research area that could benefit more people, a wide range of people, community? And that research area could last long and benefit people for a long time. So I pick energy and water because these 2 research areas are the 2 major challenges human beings are facing right now: energy and water scarcity, particularly fresh water scarcity. Okay, today I only pick one of the research areas I've been working on. That is about passive radiative cooling. And I received a grant $500,000 grants in 2019, and I might be one of the first researchers in the country studying passive cooling technology. What is that? Clearly, it is a cooling technology. We would like to cool down something. Okay, cool the temperature, in the dwelling, the house is mentioned like this, and cool down the temperature in vehicles. Okay, personal vehicles, trucks, and school buses. And this technology is passive. Okay, passive versus active. So how do we obtain cooling performance actively with the use of air conditioners, HVAC system? Passive means we abandon the use of AC. Okay, we could still achieve cooling. That's what I aimed to do a couple of years ago, and we succeeded. I'm going to show you what is that. This technology is named passive relief cooling. Okay, this material has two features. One, it is high reflectance material. It can reflect most of the sunlight. Okay, so currently, our material can reflect 99.9% of the solar energy, reflected back to the ambient. The other feature is mid-infrared emittance. This material absorbs the heat and then re-emit energy to the outer space, not to the ambient, to the outer space, out of the atmosphere. And we are taking advantage of the Earth's atmosphere. Earth's atmosphere is transparent to visible light and is opaque to near-infrared lights. And Earth's atmosphere is also transparent, 100% transparent to particular mid-infrared wavelengths, particularly between 8 micrometers and 13 micrometers, between 8 and 13 micrometers. So any surface that emit energy via thermal radiation between 8 and 13 micrometers cannot be absorbed or reflected or scattered by atmosphere. Atmosphere is like CO2, carbon dioxide, water molecules, ozone, and some other stuff. Cannot be absorbed, scattered, and reflected back to the Earth. And the infrared energy between 8 and 13 micrometers can simply go through, penetrate atmosphere, no matter how thick it is. Okay, it can go through, penetrate atmosphere, and get lost in the low temperature, dark space. So that is the fundamental, the mechanism of the passive relief cooling. Unfortunately, most of the materials on Earth cannot emit energy falling in that range of wavelengths. So my job is to tune the surface feature, to shift the thermal emission from visible light, infrared lights, even UV, to that wide range of mid-infrared wavelengths between 8 and 13 micrometers. And a couple of years ago, actually, we studied a bunch of materials. We started actually use the papers, and then we used the recycled papers. And why? Because paper itself is white. As we know, most of the papers are white. White to thermal scientists, to us, is highly reflective. White means reflective. Black means absorptive. Okay, so we prefer some surface like with white color, means highly reflective. That's why, in the hot days, in summer, actually you prefer to wear some white shirts, not the black shirts. Is that right? And that's why we targeted low-cost material, paper. And then we studied whether this material actually could emit energy between the wavelength and the wavelengths of interest, between 8 micrometers and 13 micrometers. And that is true. So I may not have too much time, so I will skip most of the stuff here. And we finished this work about 3 years ago, and we succeeded. And the fiber material, the cellulose fiber materials that constitute papers can reflect solar energy up to 96% and re-emit infrared energy up to 93-94%. They are not perfect because we study nanomaterials. And also a bunch of other research groups from MIT, Stanford, also study nanomaterials. We're taking advantage of nano engineering technology. It's not that hard, to make the nano-engineered surfaces that could emit energy up to 99% or reflect 99%. But nanotechnology, nano-engineered materials are expensive. They cost money. And as an engineer, I would like to apply our material, to benefit a wide range of people. So how do we do that? To make a technology practical. So we need to reduce the cost of the materials. Nano is a buzzword, it is a good word, okay, and it's helped me to obtain more research funds from National Science Foundation, but it may not help us get our technology out of the lab. So that's why push us to study some low-cost materials. So paper is one of the low-cost materials. And after that, last year alone, we also studied plastic materials. Okay, we studied a bunch of materials. Okay. For example, we study some low-cost waste materials from farm, the farm waste materials. For example, like a cow dung, cow manure, horse manure, so cow shit, horse shit, the low-cost material from farm, agricultural waste. And also we study different types of tree leaves, maple tree leaves, oak tree leaves. Okay, and also we study some ocean biomass materials like lobster shell, crab shell, clam shells. And also we study plastic materials because about 2 years ago, actually, I believe most of us have read articles regarding the microplastic pollution. Okay, so microplastic has been tested to diagnose in human body. So we need to actually reduce the use of plastics, and in the meantime, we need to find a way to upcycle plastics. So last year alone, actually, we published 2 papers in a leading journal, as you can see here. So clearly, my research are directly related to sustainable technology. And you see, with the use of recycled papers, just the paper itself, we could achieve high solar reflectance up to 96%. And also we could achieve high solar emittance, infrared emittance up to 92%. Like I said, they are not excellent, they are not perfect, of course. But considering the cost, they are perfect. And also we have abundant of raw materials like this. And my goal is to really apply this material to the community, to as many people as I can. And sometimes, actually, we have to learn how to compromise. As a scientist, usually I do not tell my students, you compromise. You have to chase, the higher goal. You achieve 96, next year you need to achieve 97, 99, and then 99.9. But being realistic, so 96 is not bad. What's the difference between 96 and 99? Only 3%, and then we compromise, and then there's something that we could do out of the lab. After that, actually we run the outdoor test for 4 seasons. During a year, we were able to achieve ambient temperature drop by 6 degrees Celsius, which means without turning on AC, air conditioners, we could still achieve a lower temperature indoors, about 6 to 7 degrees Celsius, less than the ambient temperature, no matter how low the temperature could be. We always could achieve 6 degrees Celsius less than ambient temperature. And after that, I founded my startup company, energy company named Planck Energies, and we started to commercialize this technology. By then, our team received a huge attention, from all over the world, from China, India, Saudi Arabia, North Africa, and European countries like Spain and France. And they all like this concept about the passive cooling, but they all question me. This material is good and also low cost, but what about the durability? Papers. How could I make a paper house? Right? The durability is a big issue. So that pushed us to study the functional materials from organic fibers, cellulose fibers, organic fibers to inorganic materials. That's how actually we study as a material, inorganic materials. And then after screening a bunch of materials, we found out a really good type of material that is a calcium-based materials, calcium phosphate. We invented a nanoscale calcium phosphate nanofibers and nanopowders, which can be used as paint additives or paint pigments. And as you can see here from these 2 animations, to the right you can see this material is totally fireproof. One of the big drawbacks is fire issue if you make a paper house. While using this material, this problem has been well addressed. Under a torch gun, this material survives. It's a fireproof material. And also, look at the color. It still maintains a white color. Cannot turn to green even. And the image of the lab, you can see this material has a super hydrophobic surface. It's good for outdoor applications. considering some dust contamination or some contamination, soil contamination. This material is perfect. So currently, my company is commercializing this. I think I still have 10 minutes. Okay, this technology, this product. Okay, so this image here just summarizes you actually know my former PhD students, and I'm so glad actually all of them actually are in academia right now. My first PhD student who graduated in 2008 already became a professor at the University of Maryland this year. And this year I graduated 2 PhD students. Okay, one went to Harvard as a postdoc, the other one just went to University of Notre Dame as a postdoc. And currently I have 4 PhD students in my lab, and I should have at least 1 or 2 openings, okay, for the next fall semester. If any of you or any friends of you, okay, who would like to do research, okay, in this field about the functional materials, or passive cooling, or sustainable technology, do let me know. My recent PhD student, actually, I just recruited a few weeks ago, was the daughter of George's son. We met all together, okay, 2 months ago at the Beijing Tongxianghui. George is the 会长 of the Shandong Tongxianghui.
Oh, okay.
Right? On that day, I just know him, and then he introduced me. So his daughter to me, and then I interviewed her twice, and then I just issued an offer letter. Okay, it's a full scholarship, okay, coming to Northeastern to my lab in January next year. So I do have fund, okay, available over there. Just let me know if you have any interest. And then acknowledge all the research funds I received so far, particularly from NASA and the Air Force. And this is my role number 1, okay, as a tenured professor and director of Nano Energy Laboratory. My role number 2, I'm also a faculty fellow at the business school at the Northeastern University right now. So I might be the only engineering professor who was elected as a faculty fellow at the business school at the Northeastern. And this is something, events that I organized. So currently I'm a faculty fellow at the Center for Emerging Markets at the D.R. Moore Mackin School of Business at the Northeastern University. Rule number 3, about my company. I founded this company about 2 years ago. And currently, actually, we have 3 full-time engineers, full-time employees, and 2 full-time interns. And recently, we just recruited a full-time co-op for my company. And in the past 2 years, okay, we already received about $1 million grants from federal agencies like NSF, Air Force, and from state agencies like MassCEC, Massachusetts Clean Energy Center, Mass Ventures. And particularly this year, actually, my company, Planck Energies, has been selected as one of the 24 climate tech companies in the state. I'm so happy. And we already attended several local and regional mentor training programs. And you can see here, okay, this image with the mirror rule. And also we introduced our product. Okay, we built a mini houses and with a cooling paint over the roofing of the mini house. And also, actually, the image on the right, actually, why I put actually image here, it may not mean too much to you, but actually it meant too much, to me. Okay, in that box, that contains okay, the first batch of our paint pigments. Okay, that was shipped to a company in France a few months ago. And also a few weeks ago, last week, we also shipped 1 kilogram of the paint pigments, okay, to a company in West Africa. Okay, this company received huge grants from the United Nations. So hopefully, they will like our paint, and then we might be able to open the market, okay, in Africa. And my role number 4, I can mention, actually, I signed a contract with NASA. So I worked for academia at Northeastern for 9 months a year. And then for the rest of the year, I worked confidentially at the NASA Research Center. So every year, I spent about 3 months in NASA. I have my own office there, and also I have my own team over there. So it's kind of a really good experience. I might be the only Asian Chinese American professor, okay, working at the NASA. So after tons of security clearance, okay, so I might be the only one, okay, who was born in China mainland. My role number 5, and currently I serve as the vice president of Tsinghua Alumni Association in Greater Boston. So I graduated in Tsinghua in 2009 and obtained my bachelor's degree, and then I joined Columbia University for my PhD study. So I graduated from Columbia in 2014, and then I became a professor directly without a postdoc. So this is my 11th year as a professor so far. Yeah. I'm sure sometimes I look young, okay, even actually when I work on campus, or in gym, okay, they ask the student ID, okay, that's great. I don't have the student ID. So I might have to leave early today, this afternoon, because actually we're going to have another event, okay, the Tsinghua Alum Association has a dinner gala with the MIT Tsinghua MBA program. So I will be there, okay, to show my support. Hopefully I will become the president next year. And also, actually, I'm the vice president of APAPA Boston chapter. APAPA stands for Asia Pacific Islander American Public Affairs Association. It's headquartered in California, in Sacramento, California, and in East Ranch. So last year, actually, I received a grant. I received an award. It's the APAPA Civic Engagement Award. Okay. From the president of APAPA in Sacramento, California. And also last December, actually, I was invited to attend events in California. And this guy here on the left, is the governor of California. And also we organized a bunch of events. Okay, I organized the Red Cross. I organized the blood drive events in partnership with Massachusetts Red Cross. So I was so proud. For the first time, actually, I organized the first blood drive. Okay, events led by Chinese American in this country. They even asked me, okay, the one actually I talked to at the Massachusetts Red Cross, they asked me, okay, I saw Chinese people don't like make donation, the blood donation. I said, no, we not only actually make donation, but also organize, the blood drives. So I organize blood drives every year. I did this twice a year. Last year I organized 3 blood drives. This year I organized my first blood drive on May 4th in kindergarten already. And also the image here, in past June this year, 2024, I went to Congress Hall in Washington, D.C. So I was knocking at one of the congressman's door, the office. So we were lobbying some bills for Chinese American history. My role number 7 as a board member of UCA. Yes, and also this year alone, as you know, I received one of the outstanding award from the UCA, United Chinese Americans. Okay, outstanding research award recognizing my community service. I want to show you, I'm a professor, I'm a young entrepreneur, but you can do more to your community. Okay, so this is something I want to show you. The capital in Washington, D.C. And also this year I co-founded NPO, a nonprofit organization named the Boston Urban Forum. And here I only showed you the 4 flyers actually we made. So we have monthly events. Okay, we use Boston City Hall. Okay, the Civic Pavilion, as our base. Okay, we have the monthly events. Our next events will be in 2 weeks on October 21st at 7:30 in Boston City Hall. And also for academia, I was selected as a fellow of SME, and I might be the youngest fellow. Okay, I was elected this year at the age of 36. I might actually already break the record. Okay, the average is 50-55. And when they nominated me last year, I thought this may take about 5 or 10 years, but I got selected as a fellow of the SME, as one of the significant society in mechanical engineers. And also the fellow of STFE and the vice chair of Optica, is Optical Society of America, and associate editor of another SPIE journal. And then I'm a stand-up comedian. Can you imagine that? This year alone, I gave 2 stand-up comedian. Okay, about 3 weeks ago, actually, I gave a 5-minute comedian show, talk show, to Joe Wang's. Right? I was there. I gave 5 minutes. Right? Wang Xi, right? And also, actually, I invited Wang Xi to visit my lab. Actually, he had a background actually in chemistry. Okay, so actually, I just showed him actually to my lab. And then marathoner. Okay, so far I run 4 full marathons and 5 or 6 or 7 half marathons. Okay, even I do not look like a marathoner right now. I will tell you the reason why. That's the reason why. I play basketball. This year, January this year, it's the Tsinghua Beida basketball. So I was the captain of the Tsinghua team. And actually we were playing against Peking University. Yeah, so I played so hard, so I broke my Achilles tendon.
Oh.
Okay, Achilles tendon fully ruptured, so it took me about 4 months, okay, to get recovered. So I'm getting back, okay, to pretty fast, okay. And I'm the captain of the basketball team. I'm also wanted to be a real captain. I already got a license, okay, for boating myself. And also you can see I already have my gear. This is Captain John and Captain John here. I already have a t-shirt which is my name, the Captain John. So I really would like to get a boat myself as a real captain. And then, like Asian American community leader and volunteer, this is who I am, standing actually in Boston Commons. And also I was invited, to be standing on Fenway Park with Boston Red Cross. I was invited to give the first speech, okay, but I thought that I was so young, so I passed this chance, okay, to Gary Yu. So he did actually the first speech, okay, on behalf of the AAPI community, okay, on May 1st this year. All the events here, almost done, actually, a few, 3 slides. And also I'm a chef. I really enjoy cooking. Okay, I can make, this American food, ham, turkey, and everything here. So tomorrow I'm also have a barbecue party, okay, in my home. So far 12 people actually will be coming to my backyard tomorrow. And then this year I was selected, I'm selected as 40 under 40. Okay, and so I was so honored. Okay, over almost 500 nominees actually I was selected. Okay, so in about 2 weeks I'll go to the Ritz-Carlton Hotel in downtown to receive the award. And last slide. Okay, so I'm a traveler. So I enjoy life. So just play this video. So can anyone recognize where I was standing? Machu Picchu, Peru. Peru, Machu Picchu. I went there this May, right after I could actually barely stand, and then because my wife, Olive took me care really well in the first few months, so I just brought her to Machu Picchu. Even I was still crippled at that time. So amazing. Okay, so thank you so much, and it's my pleasure to standing here, okay, on this stage, and I just would like to use this last few words, okay, to end my presentation today. Be a leader globally. Okay, so you might be a CEO, you are a CEO, you might become a CEO, or some of your friends might be a CEO, but no matter, okay, what roles you are, okay, you are a leader. And you become a leader, in your own company, okay, in your lab, at your university, okay, or at your community. So be a leader, okay, think big, okay, think big. Well, thank you so much for your attention.
Thank you.